11.2 is going to explore another element of arithmetic series, and that's called the sum. Sometimes we want to know the sum of all the items in a series, and to actually go ahead and physically add the first 20 even numbers would be rather time consuming. And so we have a couple of very important formulas. And these are formulas you should include in your cheat sheet. If you know the first and last term, we're going to go ahead and use this formula. If you don't know the last term, we're going to go ahead and use this formula. And our items are still, A1 is still our initial value, A to the nth is our last term, or whatever our nth term is. This n is the same as this n, same there. Here we've got the same thing, S of n, the sum of 20 terms, the sum of 10 terms, whatever n in there becomes n here. Here's your initial value times 2, and that should look familiar from yesterday's lesson. So for example, let's find the sum of the first 20 even numbers beginning with 2. So the sequence we're talking about is 2, 4, 6, 8, on down the line. So one of the things that we need to know is what is that common difference, which is positive 2. We are thinking about finding the first 20 numbers, so n is 20. So since I know essentially the first and last term, A1 is 2, and A20 is, I could go ahead and find it. If I don't want to find it, I would use this formula. So let's go ahead and use that formula first, just for experimenting, to save myself the work of writing the equation for the sequence to find the 20th term. So the sum of the first 20 terms is equal to n 20 divided by 2 times 2 times the first term, which is 2, plus 20 minus 1 times my common difference, which is 2. So the values I'm inserting here, here's my n, there's my n, and my n shows up again there. A1 shows up right here, and my common difference shows up right there. So we go ahead and do some work on that. S of 20 is equal to 10 times 4 plus 19 times 2. S of 20 is equal to 10 times 4 plus 38, which is 10 times 42. So the sum of the first 20 even numbers is 420. And so that is how you use the second formula. First one obviously works a lot the same. So in the next example, they've given me the sum of the 31st term. They've given me D, and they want A1. So I'm going to go ahead and use the formula here, because I'm going to use the second formula. I don't know what the value of the 31st term is. I only know the sum. So I'm going to use the second formula because I don't actually know the term. So I've rewritten it here for you. So the sum of 31, what do I know? I know this. I know that D is 100, and I want A1. If I know S of 31, that really means that N is 31. So I can go ahead and make my substitution. So S of N, my sum, is 124,000. That's equal to, parenthesis, N is 31 divided by 2, parenthesis, 2 times A1 is what I don't know, plus 31 minus 1 times D, which is 100. So after you go ahead and work out some of this algebra, we really just need to solve and isolate that. And so I have 15.5 to A1, 30 times 100 plus 3,000. The only way to get around this is to go ahead and do a distributive property. So I have 124,000 is equal to 31 A1 plus 46,500. We're going to go ahead and subtract 46,500 from both sides. And we end up with 77,500 is equal to 31 times A1. Divide both sides by 31 and you find out that A1 is 2,500. And that makes sense. I know A1 should be a fairly small number. If I end up with something larger as my sum, it makes sense that I have a positive number to work with here. So here I'm asking for the first 4 terms of the series. When I give you A1, I give you the nth term, and I give you the sum of that nth term. So this is a 2-step problem. So first, we need to find n. We need to know how many terms we're dealing with before we can use the formula from 11.1 to write the equation and or find the first 4 terms. So first we need to find n. So let's go ahead and use this formula because we do happen to know the first and last terms. Okay, because we know the first and we know the last and we know the sum. So we can go ahead and use this formula. So by substitution we have 129 is equal to n over 2 times 14 plus 29. So I have 129 is equal to n over 2 times 43. If I go ahead and multiply by 2, 43 isn't divisible by 2, so I'm going to clear that fraction by multiplying by 2. And so I end up with 258 is equal to n times 43. Divide both sides by 43, and n is 6. I could have, at this step, gone ahead and divided 43 by 2, had a decimal divided by the decimal. You get the same place. This just keeps the calculations a little neater. Once I know n, then I go to step 2, my nth term formula from 11.1, which says that a of n is equal to a1 plus n minus 1 times d, because what I really want at this point is d. So by substitution, a of n is 29. My first term is 14 plus I found n to be 6, 6 minus 1, and d is what I don't know. So I'm going to go ahead and clean up the algebra, and so I'll have 29 is equal to 14 plus 5 times d, subtract 14 from both sides, 15 equals 5d, so d is 3. Once you know that, and that our first term is 14, the question asks for those next terms, and if our common difference is 3, I have 17, 20, 23, and 26 by adding 3 at each step. Now with everything, there are different notations that we can use. And this is evaluate a sum in sigma notation. That's what this crazy guy is he's called sigma. And so really, we're still doing, this is the old formula, and over to A1 plus AN. Our first and last terms added and divided by 2. So we're finding a sum with a different formula, with a different set of given. This k equals 3, whatever the k equals on the bottom, is your first value of k. So that's kind of your initial value where you start. You use this to find A1 by substitution. So you let this k equal whatever that value is, and that gives you A1. This number that's on the top is the last value of k. So that really gives you that last term, that a to the nth for this formula. Because remember, the formula is the first and last term. So when you substitute 10 in and work it out, that gives you the last term in the series. So if we go ahead and do that, A1 would be equal to 2 times 3 plus 1, which is 7. The last term, we're going to let k equal 10, and we're going to have 2 times 10 plus 1, which is 21. And to find what n is, the formula for n is top number minus bottom number plus 1. So n is equal to 10 minus 3 plus 1 in this case, and that equals 8. So now what I can go ahead and do is I can go ahead and actually find the sum, because I have all of my pieces now from that formula. So the sum is what I want, S of n, and that's equal to n is 8 divided by 2 times my first term was 7, my last term was 21, and so we're actually finding, I should have substituted, we actually are finding 8 because n is 8. So the sum of the first 8 terms is 4 times 28. The sum of the first 8 terms is 112. So what should you from your cheat sheet, or what should you put on your cheat sheet from here? You have 2 formulas for the sums of a certain number of terms, probably want to indicate when to use which, and you have this sigma notation that you probably want to write and do some explanations around. And that is the end of the 11-2 lesson.